This lesson's on adding and subtracting rational expressions, so you'll recognize the flowchart on the left-hand side that we used in the previous lesson talking about multiplying and dividing rationals. The difference here is that we actually want a common denominator, and so when we create our common denominator, we're going to just simplify our numerators and then factor and cancel if we can. So we want to factor each denominator to determine that least common denominator, or LCD. We're going to leave that denominator factor the whole time, just in case something can cancel in the end. Once we create our common denominators, we're going to multiply out just the numerators and combine like terms, and then factor with hopefully being able to simplify that. So for the first example, we had 1 over 3x squared plus 21 plus 30 plus 4x over 3x plus 15. So let's start by just kind of looking at the denominators and factoring them. So starting with the first denominator, I see that it's a quadratic, so I know I'm going to have to use the product sum. But first I want to check, does 3 go into every term? And it does, so let's factor out the 3 first. So that's going to give us 3 times x squared plus 7x plus 10. And I'm not going to write out the product sum for this. I'm just going to write the factors. If I continue to factor this, I'm looking for something that multiplies to 10 and adds to 7. So I want two numbers that multiply to 10 and add to 7. And so those numbers are going to be 5 and 2. So that means that the first denominator factors to 3 times x plus 5 times x plus 2. If I also factor the second denominator, and again, I'm really just factoring this so that I can find the common denominator, I see that I have 3x plus 15, and I know that 3 goes into 15, so I'm going to factor out that 3. So if I factor out a 3, I get x plus 3 times 5 makes 15. So I can think about that denominator as 3x plus 5. So what I want to do now is I want to find my least common denominator. And the way that I'm going to do that is by identifying factors that they share and listing those. So as I look at this, I can see that they both have a factor of 3. So I know that my LCD is going to have a factor of 3. They also both have a factor of x plus 5. So anything that they share, it only needs to be a factor once because they already have that as a factor. And then whatever's left over now, those all have to be listed as well. So they shared a 3 and an x plus 5, so that's part of my common denominator. And then the first fraction has an additional factor of x plus 2, so I know that that also needs to be a piece of my LCD. So I have 3 times x plus 5 times x plus 2 as my common denominator, and notice it's actually the denominator of my first fraction. So let's rewrite this with our factored denominator. So I'm just going to rewrite it so it looks a little bit nicer. I have 1 over 3 times x plus 5 times x plus 2 plus 4x over 3x plus 15. And I was supposed to write that factored, over 3 times x plus 5. So I accidentally wrote the original version. I wanted to write the factored version. And so looking at my denominators, the first denominator has my whole common denominator, whereas the second one doesn't. It's missing this x plus 2. So remember that to create a common denominator, I'm going to multiply the numerator and denominator by that value. So x plus 2 is something that I'm going to multiply by both my numerator and my denominator. Okay, so again, this denominator had everything that we needed. So we're going to ignore it and move along. So now notice that once I simplify this, our denominators are the same. So when I do this, I can now bring these things together as a single denominator, 3 times x plus 5 times x plus 2, because they both have that. So for the first fraction, my numerator is still 1. I didn't multiply it by anything, so that's going to carry over. And then for my second numerator, I have to distribute my 4x. So 4x times x is going to be plus 4x squared. And then 4x times 2 is going to give us 8x. And so if I look at this as a simplified expression, let's write it in standard form. So we have 4x squared plus 8x plus 1 over 3 times x plus 5 times x plus 2. And so for my last step, I want to try to see if I can factor my numerator and see if it has one of these factors. And so kind of looking at it, I can see that probably won't happen because these end in a 5 and a 2, and 5 and 2 are not factors of 1. But we should always try to factor it anyway. So if I was doing this, I would need to use the star method or the product sum because of that 4, right? So I'm looking for, I have to split up my 4x because a is not 1. So I'm going to multiply 4 times 1, which gives me 4. So I would need two numbers that multiply to 4 and add to 8. And since I can't do that, that means that this guy here is prime, which means that I can't do anything else. And so just for the sake of time today, we're not going to set the restrictions, but know that the same idea that we did in the previous lesson, where I can look at my denominator and say x can't be -5 because that's going to make the x plus 5 a 0, and x can't be -2 because that's going to make the x plus 2 a 0. That still is valid for these types of problems. So let's look at B now. So we're going to start the same way, where we want to look at just our denominators to start and factor them. For this first one, I have a trinomial where a is 1, and so I know I should just go straight into looking at a product sum. So I want two numbers that multiply to -12 and add to -4. So since it's multiply to a negative, I know one's negative and one's positive based on patterns of multiplying. And so my two numbers have to be -6 and +2. So -6 times +2 makes -12. -6 plus 2 makes -4. So that's going to be this factor. For the second fraction, it's similar to the first problem where I just have a binomial, so I can just factor out a number. So I can factor out a 4 because 4 goes into both 4 and 8, and that's going to leave us with x plus 2. So now we want to look for our common denominator. And so our LCD is going to involve these values. So let's start with what they have in common, which is an x plus 2. Okay, so both of these things have an x plus 2. So that tells us that x plus 2 has to be a factor in a piece of our common denominator. And so then we need to look at what's left over from each one. And so we have an x minus 6 left over. And then from the second fraction, we have a 4 left over. And let's write that in the front just because it looks nicer to have it as a coefficient. And so that means that our LCD then is 4 times x plus 2 times x minus 6. So because they both have the x plus 2, remember we only write it once even though they share that. So let's rewrite our expression and leave ourselves some room to create our common denominators. So we've got 1 over x minus 6 times x plus 2 for our first fraction, plus 3x over 4 times x plus 2 as our second fraction. And so what we want is we want to make these all have the same denominator, that is our LCD. So for our first fraction, we're missing the 4. So we need to multiply the whole fraction by 4 over 4. And then for the second fraction, we are missing the x minus 6. So we need to multiply numerator and denominator by x minus 6. Remember that the whole point of this is to make it look the same while not really changing the value, because x minus 6 over x minus 6 really is 1. And so we're just trying to change change the way it looks without changing its actual value. So now we can see that they both have the denominator 4x plus 2 x minus 6, because when we're multiplying, it's okay if they're in different orders. So the LCD is there. So then let's multiply here. So 4 times 1 is 4. And then we have plus 3x times x, which is 3x squared. And then plus 3x times negative 6. So that's minus 18x. And so if we simplify this expression, we've got 3x squared minus 18x plus 4 over 4 times x plus 2 times x minus 6. And so, like always, we want to check our numerator to see if it's factorable. And so since a is not 1 again, we're going to have to use the star. So we know it's going to be 3x. And one of them should simplify if we can find the pattern. So we're multiplying 3 times 4, which means we want two numbers that multiply to 12 and then add to negative 18. And so if we think about these numbers, the numbers that multiply to 12 are 1 and 12, 2 and 6, and 3 and 4. And so looking at that, the biggest one is 1 and 12, and that only adds to 13. So that means that this guy is also prime, which means that this is our answer. Okay, so our big idea here is to factor and then create our common denominator. And so any factoring skill is valid again, just like it was with multiplying and dividing. So let's try one more together before you do some on your own. So these are both addition. Notice that this one's subtraction. So when I'm simplifying my numerator, it says that I have to distribute my negative for subtraction. So what I want to make sure is I'm kind of like attaching that negative to the expression in some way. Okay, so we're going to start the same way. So our denominators look very similar, but they are not the same. And so we're going to start by factoring again. Notice that each of them, 3, they both start with a 3. And if I look at all the numbers, 3 actually goes into all the numbers. So I can factor a 3 out for both of these. So if I divide these by 3, I get x squared minus 3x plus 2. And so then I want to factor x squared minus 3x plus 2. And since 2 is prime, I know it has to be x with a 1 and x with a 2. And if I look at this, since this guy, the middle term, the b is negative, that would mean that they both have to be negative. So negative 1 times negative 2 makes positive 2, and negative 1 plus negative 2 makes negative 3. So that's my factor for the first denominator. I'm going to do the same thing for the second. So I've got a 3 that I can factor out. So I'm left with x squared plus x minus 2. And so it's 2 again. And so we know that it's going to be a very similar answer because we're going to have a 1 and a 2 in order to make 2. And so looking at this, they have to multiply to negative 2, which means they have to be opposite signs, and add to positive 1. So that means the bigger number needs to be positive and the smaller number negative. And so our denominators factor to these two things. So let's use these to create our LCD. Since this is so long, I'm just going to write it underneath. So LCD is going to be, let's start with what they share. So they share a 3. So that means our LCD is going to start with a 3. And then they also have an x minus 1. So that means that our denominator, our common denominator, is going to have an x minus 1. So we have 3 times x minus 1. And then that's all that they have in common. These are similar, but they're not the same. So the first one also has an x minus 2. So that means that our common denominator needs to have that, as well as the last one has an x plus 2. So our common denominator must also have an x plus 2. So now looking at this, we have a 4-part common denominator as opposed to the 3 that we've seen in these past ones. So let's rewrite our expression with our factored denominators and kind of leave ourselves some room on the left and on the right to create that common one. So the first fraction was x over, our factored denominator was 3 times x minus 1 times x minus 2. What we're going to do with this numerator is we're going to distribute our negative so that we don't have to worry about it later. So we're turning this into addition, and we've got negative 2x minus 1 for our numerator, and then our denominator is the factored version, 3 times x minus 1 times x plus 2. And so when we compare these to our originals, right, so our common denominator, the first part of it is what we have for the first fraction. And so we're missing this x plus 2, so we need to multiply our first fraction by x plus 2 over x plus 2. And then our second fraction is missing the x minus 2. So we need to multiply that guy by the x minus 2 over x minus 2. And so this one's going to become a little bit more complicated than the last if we look at what happens when we multiply all this out. So for the first fraction's numerator, if I multiply x times x plus 2, I end up with x squared plus 2x. And so this whole thing is going to be over my common denominator, 3 times x minus 1 times x minus 2 times x plus 2. Then I have to multiply my numerators in the second fraction, and these are two binomials. So I'm going to end up with something a little more complicated. So let's start by multiplying the negative 2x times the binomial. So I'm going to have negative 2x times x is minus 2x squared, and then negative 2x times negative 2 is plus 4x. Next, we want to multiply the negative 1 times both parts. So negative 1 times x is minus x, and negative 1 times 2 is plus 2. And so we want to simplify by combining our like terms here. So if we look at our x squareds, we have x squared minus 2x squared. So that's going to be negative 1x squared. And then for our x, we have 2x plus 4x, so 6x minus x, so plus 5x. And then our plus 2 all over our common denominator of 3 times x minus 1 times x minus 2 times x plus 2. And so our goal is always to try to factor. And so if we ever lead with a negative number on a trinomial, we want to, or binomial, we want to factor out that negative number. So we're going to factor out a negative 1 from our numerator, which leaves us with negative x squared minus 5x minus 2. And ultimately, it's mostly because this is something that we can factor now that's inside the parentheses if it's not prime. And so what we want to do is look at the product sum again and see if we can factor this. And so we notice, though, that this has to multiply to negative 2. And so it's only 2 and 1. And so those will never multiply to negative 5. So if we think about that, our product sum would need to be multiply to negative 2 and add to negative 5, which means that this guy is prime. And so that is our solution for adding these two fractions together. So remember that you have the flow chart and then more detailed steps at the top of your page to help you process this. You do need to do the your turn here. And so check your answers with your teacher so that you can make sure that you're good to move on. And again, it follows very similar to everything that we've been doing. We'll finish the rest of this up next week. And so your work that goes along with today's lesson is this first chunk up to number 39. So for the rest of class, you should work on the your turn, check your answer with your teacher, and then begin the problems on page 525. You can stop at number 39 for the assignment today. Thank you.